Here's what we're really about to find out is how long will this record for. So yesterday, we ended at this point, which was converting... Kick him in the shin. We're converting... It's all good, you're good. We're converting general form rational expressions into standard form rational expressions. Essentially our goal... If you could see my screen right now, this is the weirdest thing. Our goal is to take a rational expression and get it into this form. Ooh. I don't want to use those letters. My apologies. We were using H and K yesterday, right? And we wanted to be subtraction. There we go. That was a little messy, but you know what? We got there. Our goal is to take the rational expression and write it like that. If we can take a standard or general form and turn it into this standard form, then I could tell you what this rational expression actually looks like, because I could just transform it, right? Currently, looking at this transformation, I have no idea what this rational expression would look like. I have no idea. I know that there would be a vertical asymptote at 1. But that's really about it, right? I don't know if this thing went up, down. I don't know what it stretched by. Like, I don't really know much about it besides that vertical asymptote. So, to convert it into our transformation form, our standard form, our goal is going to be to take the top, so the numerator, and write it with an x minus 1 on the top. So we're somehow going to take this thing and turn it into something times x minus 1 plus something else. Tricky, right? So with this in mind, that we want like an x minus 1 on the top, we're going to kind of work backwards from there. We're going to start with the coefficient in front of the x. This has to be a 1. That means I have to get rid of this 3. To get rid of that 3, you'd have to GCF that 3. So that means this number in front is going to be 3. And that would give me my 1x. Agreed? Yeah? Cool. The next part's trickier. So we have to somehow get this plus 2 to become minus 1 after I had taken a GCF of a 3 out. So that's a little bit trickier. Again, thinking backwards, if I had multiplied that 3 in, this number was negative 3. Are we okay with that? So if this was negative 3, then I could have factored a 3 out and it would have become x minus 1. The original question is plus 2. So I need to turn positive 2 into negative 3. I would do that by subtracting 5. So if I went back up to that original equation and I took plus 2 and I subtracted 5 from it, it would then be negative 3. If it's negative 3, I could then factor out the 3 and give me x minus 1. All right. Taking this plus 2 and subtracting 5 to make it negative 3. You can't just do things to expressions and not balance it out somehow, right? So when I subtract 5 to that plus 2, I have to add 5 to the numerator as well. So if I subtract 5 and add 5, I really haven't changed the number. right? It stayed the exact same. So I'm going to subtract 5 away from the plus 2. And I'm going to add 5 afterwards to kind of balance out the fact that I subtracted 5. So your expression would now look like this. Three times x minus 1 plus 5. My whole goal was to be able to get an x minus 1 on the top and an x minus 1 on the bottom, and I did achieve that. It's kind of tricky to achieve, but we got there. If you multiplied it back in, you should see like we didn't change the actual expression, we just changed the way it looks. Multiply this 3 back in. That would be 3x minus 3 plus 5. Minus 3 plus 5 is plus 2. I think this is the same expression as this. It's just written in a different form. That's by far, like, definitely the hardest part. We'll do another one right next to it too, so we can walk through it one more time. Usually after the second time, it's like, okay, I see what he's doing. First time is like, whoa. Like, this is weird that you're adding and subtracting 5 and you're trying to make this factor. It is a little bit confusing. Okay, the purpose for getting this x minus 1 on the top and this x minus 1 on the bottom is that now I can take this expression and I can break it into 2 fractions. The first fraction will be 3 times x minus 1 over x minus 1. The second fraction will be plus 5 over x minus 1. Again, I haven't changed anything, I'm just changing the form that it's in. So I took one fraction and I split it into 2 fractions. I split it right here, right at the plus sign. The reason I do that is your fraction on the left, the one that has the x minus 1 on the top and the x minus 1 on the bottom, that can simplify. Those x minus 1s will divide into each other to equal 1. And I now have y equals 3 plus 5 over x minus 1. Yes, sir?
Would you be able to simplify it in its earlier form?
Technically, you can't simplify it like up here, you mean?
Yeah.
You can't simplify it there because if I'm dividing x minus 1 into something, I have to do it into every term, and you would need an x minus 1 there.
Oh, okay.
So I have to split it first, and then I can simplify.
Got it.
This is standard form. It looks a little different than we're used to. They just have the plus k at the beginning instead of at the end. So if you much rather like rearrange it so it's something more comfortable with, you could. You just put the plus 3 at the end. That thing is standard form. I can tell you that the transformation on that was 1 unit to the right, 3 units up, with a vertical stretch of 5. And now I could tell you what that rational expression actually looks like, and I could graph it. Okay. First time, disaster. Second time, should get better. Your goal is to get the binomial on the top to also be on, the binomial on the bottom to also be on the top. So I have an x plus 2 on the bottom. So my goal is to get an x plus 2 on the top. First thing I'm going to get rid of is this 4. I'm going to get rid of that by GCFing that 4 out front. Everyone's okay up to there? Okay, the problem is, if I think about what I have right now, and if I multiplied that 4 back in, this would be plus 8. And if I think about multiplying this 4 in, that would be plus 8, which does not match up with our minus 1. So I need to go back to the original equation. I need to change this minus 1 to become plus 8. That way I actually can factor the 4 out and get x plus 2. To get negative 1 to become positive 8, I would have to add 9. So looking back at the original equation, I'm adding 9 and I'm going to subtract 9. And so I'm really not changing anything. I'm just going to rewrite this so that it now looks like it's plus 8. So I add 9 to the original equation and I subtract 9 to the original equation. It should look like this now. I'll do it in blue. Once I do the first, plus 9, that will change this negative 1 to be 8. We needed it to be 8, so we could GCF the 4 out and be left with x plus 2. To balance out the fact that I just added 9 randomly, I have to subtract 9 afterwards. That still stays as subtract 9. Like that's still on the outside. I'll wait a second just to see if it's like any questions. I know it's confusing. It's weird, right? That you're adding and subtracting numbers and feel like they're just kind of coming out of thin air. This is a very smart room. If you have a question, I guarantee you at least 5 more people have that same question. Yeah.
I don't even know what I don't know.
You see the graph of like what you know you don't know, and then things you don't even know that you don't know. It's like infinite. Looking at it, back to step 1. Like step 1 is this is my goal. I want an x plus 2 on the top, x plus 2 on the bottom. So that I can do this trick, right? Cancel that. If I know that's the goal, I have to factor out a 4. Like for sure that 4 has to come out. So there's a 4 in front. Yep.
Is your denominator always going to be your goal?
Yeah. Yeah, always. Like that, whatever's on the bottom, that's always the goal.
Okay.
Yeah, so if it was x plus 7, I would want x plus 7. I'm just trying to match this thing. The first thing I match is the x's. That's the easiest thing to match. Because I can do that by just dividing that 4 out. GCF it. The problem is, if I look at this original equation and I GCF to 4, it does give me an x, but it doesn't give me plus 2. Right, like that's the major issue here is I GCF and this aren't the same after I actually GCF. If I just took out a 4, it would look like this. X minus 1 over 4. And it wouldn't match. So I have to go back to here, and I need to change this minus 1 to become 8. The reason I'm saying 8 is because this is 2. 4 times 2 would be 8. If I GCF to 4, then I would get my 2. Right? Like I'm trying to think about what this number must have been, so when I GCF it actually turned into 2. It must have been 8. The only way I get 2 is if I turn that thing into 8. To turn that thing into 8, I add 9. To balance out the fact that I just randomly added 9, I also subtract 9. I think that balances it out. That means my top equation now looks like this. y equals 4x plus 8 minus 9 over x plus 2. And then I can GCF my 4 out of that, which is why I get the 4x plus 2 with a minus 9 still afterwards. Did that help at all? A little bit? I see some people nodding a little bit more, but I still see people looking at me like I'm crazy. It's definitely hard. It's like number sense, right? It's like getting just a sense for how I can manipulate numbers to match up what I want them to be. Once you get to there, you're just going to follow like the same pattern. You're going to split your fraction into two. One of them will simplify, one of them will not simplify. So looking at this, if I split my fraction into two, I would have 4 times x plus 2 over x plus 2. That's the one that's going to simplify. And then I have minus 9 over x plus 2. Reducing this a little bit, those x plus 2's will cancel. I now have y equals, I'm going to rearrange it so that our plus k is at the end. So I'd have negative 9 over x plus 2, and then plus 4. Notice that the negative I just put up to the top, right? Negatives float up to the top. I think that's the term you would have heard in grade 9. Negative goes to the top. There's my fraction. My 4 is left over, so I add 4. I think you have a couple of these in your practice booklet. They're definitely worth giving a try. And if you get stuck, like, try to refer to your notes, because it should be pretty much the same pattern, but it's not always easy to look at your notes on this question and actually match it up to another question. So please, please, please ask for help. When you do these practice questions and you get stuck, ask. This is a good one to ask on. All right. Question? Huh? No? Anybody? Yeah.
So, just looking at the practice book, I was going to give you an example from one of those.
You got one?
Yes, negative 4x over 2x plus 3.
Y equals negative 4x
over 2x plus 3.
and they want you to write that in standard form?
Oh no, never mind.
Okay, that's significantly harder.
It just has to graph it.
Okay, I was like, that is going to be a much harder example. I can make one up for you though, right? Like, oh, do you have one, Miss I?
Can you just do, it's same in the practice booklet, it's negative 2x plus 1 over x plus 1.
Negative 2x plus 1 over x plus 1?
Correct.
Wait, no. And they want that in standard form?
Yes.
I can do it. You want to try one by yourself first?
They want it in transform.
Yeah, transformation form, standard form, same idea. You want to try it by yourself? Give it a shot. I'll cut the video off right now because I think
You know, Mr. Kennedy.
if I knew how to cut it off, I would. Oh.